Hey guys, so Unit 4, Lesson 1 is a review of linear systems of equations. So just remember that a system of equations is a set of equations that involve the same variables. So in this particular case, x and y. But as long as you have all the same variables represented within your system, you're going to graph them all on the same graph. And we're then looking at where do those intersect. So they involve the same variables, and then they might have a common point that is then the solution to the system. So the solution is a point of intersection. So like this, for example, would be a system of equations. And so if I say is 2, 3, a solution to this system, then to check that, you would say, okay, 2 times 2 minus 3 is equal to 5. And you would plug this in for x and this in for y. Well, that's 4 minus 3, which is 1 equals 5. And since that doesn't work, we don't even need to check it in the other equation. Okay. I say is 3, 1 a solution? Then same thing, I would take, okay, so 2 times 3 minus 1 is equal to 5. Well, that's 6 minus 1, which is equal to 5, so that one checks. But in order for it to be a solution, it's really bad handwriting here, it has to work in both. And so we also need to check it in the second one. And so we'll do 2 plus, 3 plus 4 times 1 is equal to 7. So 3 plus 4 equals 7, which is true. And so since it works in both of them, that is indeed a solution to the system. So if you were to graph these two equations, you would see that that point 3, 1 is this point here where those two lines cross. And so it is your solution to that system. So there's 3 ways you can go about solving a solution to a system of equations. We can use substitution, where you solve for a variable, substitute that expression back into the other equation, and then once you solve for that variable, substitute that answer back in again. And so just an example of that, solve one of your equations. So like this one, you could rewrite as x equals 1 plus y, or something like that. So get a variable by itself. Solve for one variable. We could just as easily down here solve this one. It would involve some fractions if we did that. And so I always look for the easiest one to solve. So look for a coefficient of 1 because it's easy to solve for. And for the purpose of our assignment, I'll have you do one of each method, but generally speaking, I don't care. And when we take quizzes, and or probably on a quiz, I'll ask you to, but when we take our final unit test, I won't specify which method you need to use. Okay, so now this is the value of x, this whole thing. And we have an x right here. So we're going to replace that x with this value. So we have 4 times 1 plus y plus 3y equals 18. And my colors aren't changing, but get the idea, hopefully. I'm just going to solve this algebraically fairly quickly. And I got y equals 2 here. You can see my steps if you need to. I'm going to now take this value here, y equals 2, and I'm going to replace it up here because that's the easiest place to solve. But you could plug it in anywhere and solve it out. So x equals 1 plus 2, x equals 3. So the system solution is 3, 2. And we must write as a point. Okay. The next method is elimination. We are literally eliminating one of the equations. So adjust the coefficients so that they match. This one is already set up for elimination. We can do an example where they're not. But by match, we're just looking at the fact that these are both 4s. One is positive, one is negative. It doesn't necessarily matter though. All right, so if opposite signs, then add, like this says up here. If it's the same signs, just subtract. Okay, but the point is that if we add these equations down, we get 4x, and then these cancel to 0. And you want to make sure they actually go to 0. Don't just get cancel happy and say, oh, yay, that's 0. And this goes to 8. So x equals 2. And then we can take this value and plug it back into one of our equations. Now I'm going to do the bottom one. So 2 minus 4y equals negative 2. Negative 4y equals negative 4, and y equals 1. So our solution is 2, 1. Going back to the previous example for a minute, if you're using elimination and it's not already set up for it, just remember that you're going to multiply one or both equations by a value that will make your coefficients line up. So you can choose here if you want to multiply to get the x's to match or the y's to match. It doesn't matter. I want to do x's just to show you an example with subtraction. So 4x minus 4y equals 4. Make sure you distribute that all the way through to both sides of the equal sign. And then we have 4x plus 3y equals 18. Instead of adding, we're going to subtract to make these cancel. So kind of similar to your long division, make sure you subtract everything. 4x minus 4x will go to 0. Negative 4y minus 3y is negative 7y. 4 minus 18 is negative 14. So again, we're subtracting everything. So y equals 2, which is what we got on the previous page. You would see if you do x minus 2 equals 1, then x equals 3. And we once again have 3, 2 as the solution to our system. And so again, slow this video down if I'm going too fast, but this lesson itself should be somewhat review. All right, graphically, being able to do this on a graphing calculator. Let me pull up my simulator here so if I can get it. That's not pulling up, but get these so that you can graph them in your graphing calculator. So like y equals negative 2, delay, negative 2, negative 2x minus 1. And then this one we subtract the x over and divide by negative 2. So we get y equals 1/2 x plus 4. And so get them so that you can graph them in your graphing calculator. And then type that into your y equals functionality. So here, right? And then I don't know how well you're going to be able to see this, but once you graph it, so hit graph. we want to find that point of intersection. And sometimes it's a whole number value and sometimes it's a decimal. And so when it's not a whole number value, that's when the graphing calculators come in handy. Otherwise, I'm going to have you do this algebraically anyways. But hit the second, this is all backwards for you, the second trace button. We're going to calculate it. And we want the intersection, so number 5. So go down to number 5, or push number 5. And we want the little intersection. So it'll say first curve or first line. I usually scroll closer to it, but it doesn't really matter. So I take my little cursor and then just hit enter. I have a negative button, so this is going on. So we hit enter, it'll go to second curve, hit enter, and then hit enter a third time. And we see -2, 3. I know, again, that's backwards for you, but hopefully you got the keystrokes down. So -2, 3 are the solutions. Okay, so that's how you do it on the graphing calculator. I'll post a YouTube video for that too, just in case you didn't get that. So you have 3 possibilities for number of solutions, and we're almost done here. We're going to have exactly 1, no solutions, or infinitely many. And depending on what type of solutions we get, that classifies the lines as a couple different things. If you have 1 solution, this will cross in a single point, and then the lines are considered consistent and independent. Notice the no solution, the lines are parallel, so they will not cross, hence no solution. These are inconsistent, because they don't have 1 solution or any solutions, but they are still independent of one another. We don't need one to get the other. They're not relying on each other. And then this last one is consistent because it has at least 1. I forgot my solution. In fact, it has infinitely many solutions. Because it's the same line, which means they are dependent on each other. All of the answers are the same. So you have those 3 options. What that looks like when you solve them, if you were to solve, for example, this equation out, it's already set up for elimination. So I'm just going to use subtraction here. And we get -4y equals -4, so y equals 1. Plug that back in, and x equals 4. So we can see this one has a solution of 4, 1. Whereas this one, if we multiply, for example, by 3, then that equation becomes 3x plus 12y is equal to 24. And when we subtract this down, this equation, then this goes to 0, this goes to 0, this goes to -22. And so 0 equals -22 is not true. So there's no solution here, meaning that the lines are parallel. Here, once again, I tend to just use elimination a lot of the times. If you want to use substitution, that's fine. But I'm going to multiply the top by 3. Well, yeah, multiply the top by 3 and the bottom by 2 to get my x's to be the same. So that gives me 6x minus 18y equals 30. On the bottom here, I get negative 6x plus 18y equals negative 30. And when I add those down, I get 0 equals 0. So this is all solutions or all real numbers. So just to give you an idea of what all of those look like. The last thing is your word problems. Method of solving is the same. You're going to use substitution or elimination. So it's really just about setting them up. And we've done problems like this before as singular. So you can check unit 1. Or 2. I can't honestly remember where we did these mixture problems, but we're going to use 2 equations for this. So we have rate, time, and distance for this one because we're talking about a speed from Fargo to Bismarck. So we'll say to Bismarck and then back to Fargo. Or put there and then return or something like that. But his distance was 180. He's flying into a headwind. The trip took him 2 hours. And he's fighting against the wind. So his rate on the way back, the wind is still blowing at the same speed, so the return trip only takes 1 hour and 12 minutes. Which is 1.2. If you're wondering where I got that, I took 1 plus 12 divided by 60. And how fast the wind was blowing. So the distance is the same. Okay, so here's where your variables come in place. We don't know the rate of the plane. And we don't know the rate of the wind. But we do know they're both constant. So on the way there, we have the wind pushing against him. So we're gonna, it's not helping him. On the way back, it is helping him. And so 1 we subtract and 1 we add. Remember, rate times time equals distance. And because they are both the same distance, we can set these equations equal to each other. So 2 times x minus y is equal to 180. And 1.2 times x plus y is also equal to 180. So for this one, you can use substitution or elimination, but distribute and solve. I would probably still use. Okay, I just solved this all out step by step, but again, it's the same method. So I used elimination, so I multiplied through 0.6 to get them to all be 1.2. You could use substitution with this fairly easily to divide both these by 2 and add y over, and then substitute it in. Solved for x and then plugged that in and solved for y. So 120 miles per hour for the rate of the plane, 30 miles per hour for the rate of the wind. This is asking for how fast the wind is blowing, so 30 miles per hour. Okay. This one is a mixture problem, so we've again done those before. You have part 1, part 2, and your mixture. We're doing this one as a system. If you would rather use the linear like we did before, that's fine. Remember, you have percent times amount, percent times amount is equal to the percent times the total amount. So you're just plugging those in. And so we have 300 milliliters of the first solution and 600 milliliters of the second gives a 15% acid solution. But we don't know how much of each, and so that is where our system comes in. So we don't know the percentage of each, so times x times y. But if we blend 300 and 600, we do know that we have 900 total. And you can use decimals here. Just know that you'll get a percentage as your answer. The second one says 100 of the first, same x, plus 500 of the second. So same y, same percentage concentration of that second one. Gives you a 12.5% solution. This time we have 600 milliliters total. So total amount, I'm adding these two values together, if you're wondering where I'm getting that. And that's your equation. So you would, again, use substitution or elimination to solve. So, okay. I used elimination by multiplying here by 3, multiplying this out, and making sure I distribute the 3 to every single thing. And then subtracting down, I got y is 10, and then I plugged that back in just right here, and got x was 25. And so understanding what that means, we used x for part 1, so that solution 1 is at 25%. We used y for part 2, so solution 2 is 10%. Okay, so understand what your answer means. Sorry for the length of the video. I was really going to try to keep that to 15 minutes. But let me know if you have any questions. Make sure you do the practice assignments post in the notebook. Thanks. Bye.